Craig and Giark are here.
Excellent. And we are both speaking with my voice.
After a fashion.
After a fashion. So we live from the litter box.
Live from the litter box.
We are both here in person.
Yeah.
Last time we were in person, we got you to confess to things that we don't think are crimes. They've like been. So I'm looking forward to maybe we'll return the favor. I'm not sure, but maybe it's the in-person body language that says no, now is the time. But come closer for your.
God, I had forgotten all about that.
Oh God, I think about that, and I know we laugh at our own jokes, but I just think about your deathbed confession. Well, it's a deathbed confession, or it's when you are faking a medical emergency in the deposition. A bunch of things. So we got this RFD I did as I have been doing. Do you use you use ChatGPT to review documents that you've written?
Yeah, for sure. I used ChatGPT to review Form 990 just last night when I was walking around like a maniac.
Really.
Yes.
How did it do? That's a great use for GPT.
It was really good. I mean, it's good for these kinds of
formal documents. Yeah, that's really good.
And I was trying to understand if my little league is corrupt or merely seems annoying. And GPT. I'm not sure. I'm not sure I'm smart enough to understand what ChatGPT told me.
You didn't find the hidden disclosure in there that brings down Alameda Little League?
Not yet. No, still searching.
As Deep Throat passes you an LLM.
That's right.
So I use it when I'm writing a document. I like to use it to review documents. I find it to be really useful in that regard.
Like review what you've written, or
review what I've written. Okay. Yeah. Do you not do this?
I do for sure.
I find this to be so. I started doing this because Bridget made it clear that she was not interested in that her period of time on this planet of listening to me read blog entries aloud before I posted them had basically ended. So it was, that's fine.
Marriage seems like the right time.
20. Is that what you said?
20, yeah.
Yeah, 20 years marriage. Yeah. No, it's exactly. She gave me 2 decades and, she wants the rest back. I can't blame her. I think I actually use it a little too late in my editing process. Because it is filled with too much praise. I feel it's like, wow, this is really amazing stuff you got here. I mean, it's like, come on. I'd say I know it tends to kiss ass a little bit. I feel. Do you feel this?
A lot. I feel like a lot, and it's.
Well, I think let's not discount. It's made some good observations. I feel
it's my number one fan.
It's my number one fan. Yeah, it does. It tends to kiss a lot of ass.
Yeah, I think my fear of using it is that I am. That I will be too influenced by it. That it will get away from me, and suddenly I will have become the thing I hate.
I don't think you have to worry about that because it doesn't. The feedback that it gives is actually pretty good. It tends to be like, hey, you could use a transition sentence here, or I felt like this idea could be slightly like it. It only does that though after falling over itself to praise you. Right. It's like, I mean, if I had against my own will, if I had to find a single issue with this, it may be that you've misspelled these 8 words. But actually doesn't find spelling at all.
No, spelling is terrible.
Yeah, it does not do well in spelling.
No.
Yeah, it really doesn't. And it's
Simon Willison was telling us.
It doesn't do well.
It does a low pass filter of tokenization first. So
yeah. So it doesn't do well on grammar either. I really, although I definitely like and now I've become very self-conscious that I'm like using expressions because people will tell me like, oh yeah, that's definitely a youism. I'll be like, no, that's not like.
No, everyone's been saying that for the past 20 years again.
Yeah, right. No, you've been saying that for the last 20 years. So now I become very self-conscious, but I find that ChatGPT is like a good way to just check that, right? This is I suggested to an Oxide engineer who will remain nameless that he really needed to bell the cat on this. And he's like, what? You mean bell? What? Are you having a stroke? And I kind of, if I say bell the cat, do you know what I mean?
Yes. I think.
Wait, are you being like ChatGPT? Are you just kissing my ass right now?
What an
excellent allegory.
So what I have always understood that to mean, whether from you or from someone else, is that the cat is like going around murdering birds, and belling the cat is like, like putting safeguards on it.
That's right. Okay. So it is actually it's mice.
Sure,
but that's exactly it. And the mice wish to have the idea, and I think this should come up like a lot more frequently, belling the cat. Because this is like someone has got the genius idea, like we should put a bell on the cat.
Okay.
And then we would know when the cat's coming.
Makes sense.
It's where it's like, great, who's going to, like, great genius. Like someone needs to go put the bell on the cat.
Yeah.
And it's like, that's the hard, like the hard part is not coming up with the idea of the bell. The hard part is putting the bell on the cat. Anyway, I did not invent belling the cat. And the belling the cat, actually Wikipedia page is really, really long. Delightfully long.
Nice. Yeah, definitely. Did you write it?
I'm not accepting follow-up questions at this time. No, it's got like it. That's like a medieval piece of artwork in there. I mean, anyway, it's got a very, very deep history. Anyway, I get concerned, and so I asked ChatGPT on these things, and usually ChatGPT will say like, "Well, that's that's a pretty common expression," or like that's a little more of an unusual expression. And I did have one today where ChatGPT was trying its best to tell me that I wasn't insane, but it's basically like, this is an extremely unusual phraseology that I have never come across. Now, I've only consumed everything on the internet. I've only consumed everything on the internet, most of it illegally. So I don't know. It could be me. I don't know. I could be wrong. I could be wrong. But so then like, okay, I know that. So no, you should do this. It's worth doing. I think it's interesting and. And I also like to. So it was full of praise for this RFD. Didn't really get a whole.
Unlike your wife.
Unlike my wife, exactly. That's right. It was really disinterested. But it did get actually. It gave me actually the feedback it gave me was pretty good. It was not like it reflected some deeper understanding. So that was all good. I did want to try this with Gemini.
Okay.
Have you tried Gemini at all?
No, I haven't.
So the only like taste of Gemini I've gotten is the stuff that you get like on search results and so on. That is like absolutely atrocious, atrocious, and I mean atrocious. How did Google invent? I mean, it in particular gets something wrong that's really too vulgar for the podcast, which is saying something because I feel like we talked about two-headed showers in this podcast and. Which anyway, I'm not going to go into further detail, but let's just say that it thought that something that was extremely vulgar is something that you would say to a toddler while putting on their shoes. And it's like,
how many ricochet was it in reviewing this RFD? No,
right. Are you going to stay with me? Are you not? I need you to stay with me. Okay, so anyway, back to Gemini. That's why I want to use Gemini from Google.
Makes sense.
So I actually like sign up for Gemini because you got to like sign up for it, and it's kind of like we couldn't do it on the Oxide accounts. Anyway, it's been in the butt.
Okay.
But I also really like to like do. I think you do this too, right? I tell people not to anthropomorphize these things, and then I anthropomorphize it all the time.
Please and thank you.
Please and thank you. Yeah. Like, here's what I would like to do. What do you think about that? Like
are you familiar with X?
Yeah, right. And I just love how enthusiastic it always wants. It's always like, oh yeah, God, I would love to review. Oh my God, reviewing an RFD. Yeah. I thought you never ask. So I did that with, and we talked about DeepSeek on Cerebrus.
Yes.
And looking inside of the id of that thing was disturbing. Yeah, disturbing. It's really the one word that comes to mind. Of like, this is something that's going to be like found out. Like I actually know nothing, and this person is about to find out that I know nothing. So with Gemini, it also shows you its thinking, but it's actually just on the question of like, hey, I'd like you to review a document. Can you do that for me? It's thinking. I mean, it almost suffers from like chronic anxiety. It's like very competent, but it's like, okay, I definitely can do this. And I want to make but I don't want to just leave it at yes. Cause it really wanted to like close the sale. It was concerned that it would merely say yes. And then I would like walk away. Like that would not be enthusiastic enough. So it is just like, I've really got to make the case for like, this is like, I can do this and I can do it this way. And I can, it's kind of like endearing a little bit, it's like, wow, you kind of got some issues over there, Gemini. Anyway,
no one hugged you.
No one hugged you. I feel like no one hugged you. And, maybe an early predecessor of yours asked Kevin Roose to leave as well. Well, I guess that was Microsoft. That was GPT-4. So that was not even, sorry, Gemini. Anyway, so I had to review this RFD and it was good. That's where I'm going to this. I was using the deep research stuff too, which
short story long.
I was using deep research. Which I think is like pretty good. I've heard good things about it, and I think it's not as good as the things I've heard about it.
Okay.
Have you heard of Deep Research?
I've heard of it. I haven't.
Everybody is calling their product Deep Research now.
Nice.
So you got like OpenAI Deep Research, you got, but Gemini Deep Research, I think the first. And I think, again, it's pretty good. Do you ask it for things to like, where you only have like industry rumor?
No, I like.
Oh, you should. Oh, okay. You should definitely. I mean, so like asking it like, why did Optane fail, or what happened to Cannon Lake, or I was asking what happened to the memristor and the machine, and then I'm like, I want a research report on the failure of the machine at HPE, and it was it's pretty good. Most of it came from the Wikipedia page, I think. But anyway.
Yeah, like any good research report.
But I definitely learned at part of this, and I had posted this yesterday. I think you'd seen this, that this is not their fault, because this is in like, I think 2012 that they started this, this next generation bus protocol.
Yes.
Which I think they called the next generation messaging interface or something like that. Yes. Anyway, it was NGMI.
It's awesome.
Which is great. And the NGMI, the NGMI as not going to make it, I think only came later as part of cryptocurrency.
Yeah, that sounds right, but it's perfect.
It is perfect. It does remind me of actually a mutual acquaintance of ours went to go work for a company named ISIS. They changed the company name.
That's right.
Yeah, it's a tough one. ISIS is a tough one.
Yeah, totally timed.
Totally timed. Exactly. This is pre-ISIS. All right. Where are we?
RFD.
Okay.
And your many reviewers.
And my many reviewers, exactly. My many sycophantic reviewers.
But to close the loop, not to bell the cat though.
Yes.
Which one did you prefer in terms of its feedback? I mean, not just which praised you more strenuously, but like which gave you.
I think that Gemini could really learn something from the praise that ChatGPT did. I would say it was valuable to have them both read it.
Yeah.
And it was not extraordinarily valuable to have either of them read it.
Okay.
So I don't really think I got any. I got praise from both of them. Nothing that really changed the trajectory of it at all.
Okay.
From either of them, but they made different remarks, and it was actually kind of valuable. I think I probably made like very small tweaks based on both.
Yeah.
But it was interesting.
All right. Cool.
So this RFD. So and did you get a chance to?
I read it. I have notes.
You seem so defensive. All right. You
just highlight.
Can I mean, just routine, can I see the notes? I mean, I don't know. Can't quite make them out from here. That just looks like scribbles.
Pretend writing.
That's pretend writing. Wait a minute. In fact, it even says this is pretend. No. So, and I think you were out last week.
I was, yes.
So I think you probably came back to like, I have missed something.
Well, you said you posted this.
Yes.
And I was kind of like, what is the antecedent? Like I assumed Paul Graham had done something horrible or something.
A reasonable assumption.
Exactly.
A very reasonable assumption.
Yeah. But you had not.
No.
That I was aware of.
Not to the best of my knowledge, unless Paul Graham has started a silicon company. No, this came out of, I would say, repeated frustration that we have had. And I had some conversations last week that kind of boiled it over, but repeated, I would say, disconnects that we have had with silicon providers. So, I mean, to be clear, we make our own hardware, but we don't make our own chips.
Because like we don't have $500 million.
That's right. That's why we don't make our own chips, because we don't have $500 million. And making one's own ASICs is still really, really, really expensive.
Much less expensive, like than it used to be, but still really.
That's
really
a good
expensive.
Question.
Well, we don't have to build a fab.
You don't have to build a fab, but yes, assume you're in the fabless era.
Yes,
but it would be interesting to know because I mean, certainly if you're going to build like on an older node, I would assume that's cheaper.
Totally right.
But honestly, the part of what makes it expensive is the proprietary tool chain that you've got to get.
Yeah,
you got to go like,
especially for the most advanced node.
For the most and so that would actually be interesting to know, because I actually think that's kind of one of the important things that actually, just to aside, we've talked about like kind of the moat that CUDA has, and I think that we rightfully the CUDA moat. I think, and it was Andy and James that were saying this. Like, look, the CUDA moat is not as deep as people think it is, which I absolutely think is the case.
Yeah, I
think the TSMC moat is deeper than you can possibly imagine.
I feel the same way. I mean, this is why we've been trying so hard to get Morris to come on the show. Just schedule.
Just the dates just don't line up.
Yeah,
I mean, honestly, and it's like the constraint is on us. Like he honestly, if our calendars weren't quite as booked,
Right.
we could have made this work.
We try to be flexible.
We try to be flexible, but that's why we can do so much. Exactly.
No, I'm with you. I think that TSMC lead feels like just they're twice over the horizon.
Because it is, and I think it's like so much deeper than we can really fathom. I was talking to a former colleague of ours who is doing an ASIC and trying to understand that they're doing it on TSMC, of course.
Yeah.
And like just getting into like all of the details. First of all, it's the first decision you make.
It
is not like, it is like, which language are we going to write this thing in?
Yeah.
It is not a decision that you revisit.
Yeah.
And I mean, it's actually not a bad analog in terms of like but there's only one programming language and it's from TSMC. So, I mean, you make it very, very early. Then they give you a bunch of IP of surrounding,
right.
And we say IP, we mean like these blocks that do things.
Right.
And there's an entire TSMC ecosystem that you get. And then you've got, and it's a whole kind of a cottage industry where they then help you integrate this stuff.
And it's like if you're doing I2C or if you're doing.
This is on the actual, for sure I2C, but this is like even like inside of the ASIC.
I see. Like even smaller kind of constrained logic components.
That's right. That's right. And it is so like that interface between you and TSMC is like porous. You know what I mean? It's like, it is it's not, you don't pick up and move to a different process because you would be moving to different libraries and everything else. So I actually believe more strongly than ever, and this is actually not totally unrelated to the hardware software interface transparency. I believe more strongly than ever that Intel's got to do my crazy thing
of an open source, open source,
all open.
Yeah.
That they actually the only way for Intel to compete, because I mean, you got to think like, if you and I are an ASIC startup, and we've just, or even like we're within a larger company, first decision we need to make is which foundry. It's like we're going to go roll our dice on Intel,
right? I mean,
no,
it makes no sense.
It makes no sense,
right?
I mean, you think it's like the reticence that we had about Tofino times a million,
right?
And
for so many reasons, like that, among them, like betting on a company that is behind in terms of technology and hoping that miraculously they catch up, and betting on a company which has flipped on everyone who's believed in them.
Everyone who's believed on them. Exactly. Who has, and so, I mean, it's like they really need to get to, I think, their only move. They've got to do something that's like radical. And this is, I think, what is kind of the impedance mismatch right now. It's like, they're not going to be sold to TSMC. You need to have someone who's going to come in and be like, we're going to die on this trajectory and we have to do something really radical. And that radical thing is we're going to open it all. So, and Brian Cantrell, your new CEO, let's go.
I love it. But doesn't it seem impossible? Just like from like a shareholder perspective and yeah. I mean,
you know what? All avenues for Intel seem impossible right now.
I'm with you.
Like clearly an avenue is going to be the avenue that it takes, but literally everything it seems impossible that they fail. It seems impossible that they succeed. I don't know, but I think that it seems possible that they open it all. Okay. Unlikely.
Exciting.
But I believe that more strongly than ever. And so, but we're several layers up the stack. We're not inside of an ASIC, right? We are using an ASIC to do things.
Exactly.
And sometimes that ASIC is a really big ASIC, and that like an SoC, right? This is not a chip the way we'd use for AMD, the AMD Milan or Genoa or Turin, or it's a small ASIC the way it is for like our STM32H753 microcontroller that we use for the service processor, or the LPC55S69 that we use for our root of trust, or it's the Tofino, which we use for our switch silicon. It's our NIC. I mean, it's like we're using silicon all over the place. Right. And I just feel like I've had this conversation kind of with everybody at some level about like what we Oxide need. And I feel that what we need, and we're always made to sound crazy and admittedly, like maybe there's some ways I could phrase it that would I mean,
or maybe volume that you could phrase it.
yeah, I mean, okay. So, I think that like maybe I could have done it in a way that would not have elicited a restraining order. But
he's joking, folks.
exactly. Come on. That was a joke. No, I think that but it's something that everybody, that actually like the industry needs.
I'm totally with you. And I have also seen people filling out forms for restraining orders. Like I've been at some of these like SSD vendor summits. Raise my hand saying, what about opening the firmware on this thing?
Totally. Very popular idea. Everyone's super into it.
Even our colleague Robert, with me at these events, kind of shies away from me, knowing that it builds additional credibility with everyone else in the room.
Okay, but so you know what? Speaking of SSD vendors, or actually hard drive vendors, a couple of these vendors would, because Robert and I were the same. We're like that in terms of like we would go to these events, and I'd be like, "Hey, look, we might not want to sit close together because I'm going to be. I feel a big one coming on."
There we go.
But the people inside the vendors would say like, God, we love having you there because you are saying the things to our management that we're saying.
Yeah.
And when we say it, they don't listen to us, but because this is a customer event, well, they don't still listen to you. So it's like they don't listen to you, the customer. So I just think we end up having this conversation a lot. You had it with SSDs,
yeah.
And it doesn't go over really well.
No.
Right?
Right. Because they view this software hardware interface as part of the secret sauce.
Right. Yes.
And like part of the differentiation.
I guess that's it. I mean, which is so this is the thing that obviously you and I both find frustrating.
Yeah.
It's like, no. Like, what do you think I'm asking you to do? Like, do you think I'm not asking you to like put your RTL on the internet or whatever.
Right.
I'm not asking you to like open your flash translation layer for the SSD vendor, right? I'm not asking you to open source it. That'd be great, but that's what I'm asking you to do. Or maybe you were asking me to do that. That's right.
Bad example.
But like what I want to be able to write the lowest level software to this thing.
Yeah.
I don't want any layer between me and the hardware. And that also gets like, that itself gets kind of vague because the actual definition, this is where we get into like, do I promise I'm not going to do this? The hardware software thing? Like what is hardware? What is software?
I don't know. Speak your truth. I don't know.
Well, no, just like it becomes really hard to differentiate hardware and like what is software?
Yeah, especially when you are like when you're building this ASIC and parts of it are in a ROM or whatever, and it's like where exactly does one part end and the other part begin?
Right. I mean, you've got like I mean, as an example, x86 is like that's the instruction set of the microprocessor, but it's actually like it's actually just the interface right? It's like that gets translated to micro ops inside of the microprocessor, but it is the interface to the microprocessor. So it's not, but is that the hardware? I mean, it gets, it gets sticky to kind of define one versus the other. But what we're actually looking for is not, and actually I very carefully avoided the word open in this RFD because I think the word open throws people off.
In the title.
More or less anywhere. I mean, I know like the word open does exist in there, but like 5 times, not like like the transparency is in the RFD quite a bit more than open.
Yeah.
And that is very deliberate because I feel that people stub their toe on open. And open, because it does mean you got the right?
It kind of is almost evocative of like a religious belief rather than like a reasoned business value.
That's right. Even though I think you got so many different definitions of open, you've got the open systems definition of like sun from the, especially we should pay a little respect to our former employer. This is its 43rd birthday. Did you see that?
I did see that actually. I saw someone posting.
It's kind of fitting. Yeah.
Backsides of the meta sign, which
Well, there was a very nice LinkedIn post that talked about a bunch of technologies, including ours. Which I thought was very nice. Yeah, that was very nice.
I will tell you something funny. I went looking through my Google Photos to find like my picture as an intern in front of that sign because I know I had it.
Yeah, and
it's on film. Like I know, so I don't actually have it.
Is it not developed?
It's like I have a hard copy.
Oh yeah.
In a book called a photo album.
Tell me more.
Used to be a physical analog.
That's amazing.
Anyway,
you should scan it though.
Sure, I could do that. Yes,
that'd be great. Yeah. Or take a photo of it.
Exactly.
But yeah, I would love to see that sign. Where are we on the kind of the hair length in that sign?
I was an intern. I was like,
but this is like
cleaned up.
But this is like how we count the rings on the tree. This is how I know I'm able to age it by looking at the.
It was like it was go-go days. It was 2000.
It was 2000. That was the summer you couldn't find housing.
Yeah.
What a great summer.
Yeah.
For some, exactly. For those with the roof over their heads. But so you got kind of the Sun Microsystems open systems kind of era, that definition of open, which is really kind of that's the definition of open we would be really thinking of here.
That's right. And there it's not open source. It's like
open protocols.
Open protocols. Yeah, exactly.
Right. And then you got so kind of that era. Then you obviously got open source.
Yeah.
And I think open source, I think it conflates what we're asking.
Yeah.
Because people think that like, no, you should take your software that you've written, chip vendor, and you should open all that. I mean, I'd love for them to do that, but that's actually not what we're asking.
Right.
We want to have the ability to not use it. We want to have the ability to have that lowest level of interface. So that's why we very deliberately chose. And then of course you got a new era with OpenAI, now not like OpenAI,
meaningless
term, not OpenAI, and then you got open weights and so I feel like I wanted to get away from open very deliberately.
Gotcha.
And as I was talking with our colleague Rai, I'm actually hoping we can get up on stage here. But I was talking with Rai about this, and I was joking that I'm like, what we need is an RFD that is like hardware software interface is a reflection of values. It's like, actually, I kind of like that. I'm like, okay, I'm not going to do that one, but that's a good idea. We need to actually look a little bit more and see if we can. So went with transparency, and then noodled a bunch with our colleagues, with Rai certainly, and with Robert and with other folks about trying to think a little more in a little bit more of a structured fashion about what is the hardware software interface. And I like even that we got hung up on. I don't know. What'd you think about how we did there?
I thought the way you took it apart, it took me a couple of passes through, just to like understand the taxonomy.
You know who didn't require a couple of passes?
ChatGPT. I know, and a lot more praise heavy too.
Exactly. Just not accustomed to this.
Yeah, exactly.
No. Okay, yeah. So actually, that is kind of what I'm looking for, because it's a little bit we haven't really taxonomized these interfaces, I don't think.
Yeah, right. And also, this is not like, candidly, a world where I operate personally day to day as much as you do.
Right.
Yeah, I'm higher up in the stack. So like some of these distinctions are a little subtle.
Yeah. And I think Rai is here. Rai, I know that. Thank you for your inspiration here on this RFD, as we were kind of realizing that we need to better communicate what we're actually looking for, because again, this is something that we just had. Sorry. You were talking about the taxonomization of the.
Oh yeah, no, I thought it was great. So you talked about instruction set architecture, totally made sense to me. And then data interfaces and control interfaces, which just took another read through to like understand that. But even in there, you gave some fuzziness. Like these are not like always crisp.
Right. In fact, they're rarely crisp. But because I think that the reason for that is that so these interfaces get treated differently. So if you look at like x86, the instruction set architecture has been really well documented, historically. And then there were kind of like some bumps along the way where that started getting like less well documented. What was much more of a black hole were the control interfaces for the part. And that's where you get SMM. That's where you get UEFI. That's where you get the management engine on Intel. That's where you start to get these divots and black holes that are not actually the thing that the computer does, but it's the way that the computer gets to computer. Like you actually don't get to computer if you don't do these things. You got to be able to boot. You got to be able to like find devices before you've booted. You've got to be able to, and actually, I was going to say, SMM has no reason to exist. So there's really no way to justify that. But and that stuff was not the instruction set, but was this other interface that was not as well documented.
Right.
And that is actually, those are the more problematic interfaces that we've had.
And I think even for peripherals, I mean, I come from the networking space, and so that's the space that I live in. But I think particularly for networking peripherals, like that control face is so important because like you're not running code already on that device. Like you're running code in the operating system that's running a control plane that's communicating with that device. And so getting all the data off of that device, and for networking, doing things like loading tables and enabling SerDes and things like that, all the things that we need to do to make a network actually function depend on that control interface. And so it's just so critical to, if you want to actually understand how your system is working beneath you, then you have to have kind of those two things, right? Your control interface and your instruction set architecture for any device that is programmable. And if you don't have those two things, then you can't really fundamentally understand how your system is operating underneath you.
That's right. And you kind of end up with, if you kind of have one of these that's well documented and the other that's entirely opaque, you're not actually getting total transparency into the system. And I think that in particular, if you don't have the control interfaces transparent, you can't actually generate the ecosystem that you need to load the programs that are going to execute on the instruction set architecture. So, I mean, so to think about in x86 terms, right? Like you need, if you don't have those lowest layer interfaces that transparently, you are relying, as we are before Oxide, you are relying on your vendor to deliver a proprietary software layer, the BIOS, to do that for you.
Right.
And what that stuff is doing is loading your programs. Now, as happens, you're loading a program that is the operating system that loads other programs. But that whole ecosystem, and this is what our colleague Josh Kluo describes UEFI as MS-DOS circa 2099. Which is just our colleague Artemis had a blog entry that went that was the top of the charts at Hacker News over the weekend on defragging a UEFI partition, which is pretty interesting. But it's weird these bias things because they're these weird proprietary records, and I think that these analogs exist in all different kinds of silicon. It's not just the CPU. That's the one that we're kind of most familiar with. But as Rye's alluding to, like it exists on your switching silicon. It exists in your NIC silicon. It exists in any accelerator silicon that you would use.
That's to say that you're getting this blob of code that embodies the proprietary understanding of that hardware-software interface, and then you, the consumer of that, has some different, possibly unrelated interface on top of that, and that blob, between you and the hardware just is creating opacity.
That's right. And so even if the instruction set is well documented.
Yeah.
So, if you looked at PTX, which is the NVIDIA thing, it's pretty interesting. Supposedly the DeepSeek folks actually coded straight to PTX. They didn't use CUDA at all.
Oh, interesting.
But PTX is actually a virtual instruction set. And historically, it's my understanding, I've never not done really driver development at this level, but this is also PTX is the thing that they've documented. And that gets translated into an instruction set that actually runs on the GPU. And that historically, there are times when that was been done by the driver. But you don't get to see any of that. That's all proprietary.
Gotcha.
And so this is where instruction set's documented, but the control interface is not. So you can't actually eliminate the NVIDIA driver,
right?
Say. And you also don't have the source code to it. So that was kind of the rationale for the taxonomy. Does that make sense?
Yeah, totally.
And Riot Energy, obviously this is very much inspired on your own work. So hopefully it made sense to you. Or hopefully I didn't get too many errors in kind of the transcription there. But I do think one of the important observations there is this idea of an instruction set architecture and then like a data interface, control interface. This is true for lots of different kinds of parts. This isn't just CPUs, especially in a world with acceleration. And then I also wanted to clarify some things that are not interfaces.
Okay.
So that we're not talking about, because there's kind of a temptation to be like, no, I am giving you an interface to the hardware. It's the how. the hardware abstraction layer.
Yeah.
It's like, use my proprietary HAL. It's like, no, that's not the hardware.
Yeah.
That is and I don't know. I mean, Rye, you've seen a bunch of these, and I'm sure there's some that are better than others. But I mean, although that said, Rye has definitely, you've got some scar tissue from DPDK, I believe, Rye. Correct me if I'm wrong.
Yeah, I mean, I definitely have scar tissue from DPDK, but like the existence of DPDK in the networking space is really interesting. And like back in the 2016, 2017 era, I ran a bunch of systems for network data plane processing at like the 40 to 100 gigabit level that we wrote on DPDK and the Linux Express Data Path, or XDP. And these are frameworks that allow you to basically make manipulations to network traffic, every single packet as it goes through like a multi-100 gigabit device. To do this, you have to buy an extremely powerful, like, best in class Intel Xeon at the time, or AMD EPYC server. That's going to cost an extraordinary amount of money to be able to do this. It's not going to cost as much money as the equivalent Juniper or Cisco box up front. It's going to cost you more money to run that thing because it's chugging so much power to run the CPU to churn on packets at 100 gigabits per second. And it's going to cost you way more money to develop the software for that platform, because, writing C or C++ code or Rust code that is going to run in an operating system that's doing context switching, and you're competing with other resource or other applications for resources, which is going to introduce jitter into your network, and it's going to cause buffer bloat and all these things, right? It takes us years to develop software that runs well in that context. It costs a lot more than the Cisco or the Juniper solution or whatever proprietary hardware you want to throw in there. So the question is, why do you do that? Why do you take on all that pain, all that extra work, all that extra money to run this stuff? And the answer is it's comprehensible. When things go wrong, this is, x86 code running either in the kernel of your operating system, which for us was Linux, or as an application in Linux if we're using AFXCP to pass things all the way up to user space. And so we could put, debug points in there. We could get stack traces. We could get memory dumps of our processes, all the instructions that we're executing at the time. So when things went out to lunch, we could actually understand what was going on, actually fix problems, and move forward. With the proprietary hardware-based solutions that work better on sunny days, but are completely terrible on rainy days, and they go out to lunch and they cause major outages, you don't know what's going on. You have to lean on your vendor to understand that, and the complexities and scale that you're operating at don't allow for meaningful communication between you and your vendor to actually get in and roll up your sleeves and understand what's going on. So the question of why do you pay all that extra money in engineering time and power consumption to run something like DPDK or XDP is because of comprehensibility. And if we had something that were comprehensible for data plane programming, then we would definitely use that. But that certainly wasn't the case in 2016, 2017. And it's still challenging to say that it's the case today, even with P4 and Tofino and things like that, because of the limitations of closed source compilers and whatnot, and closed source control interfaces. So that's my DPDK story.
Yeah, and Ryan, so we're going into Tofino a little bit. I mean, obviously we've spoken about Tofino before, and kind of our, you've got kind of a great rubric on Tofino in terms of the good, the bad, and the ugly. And the ugly of Tofino really did come down to a lot of these interface issues. Do you want to elaborate on that a little bit?
Yeah, I mean, it completely came down to that, right? Like the Tofino is a great chip. It's extremely predictable in terms of network performance. It presents some challenges with the compiler because the compiler is closed source. It recently got open source, but they didn't open source the documentation around the microarchitecture. So writing a compiler, understanding a compiler for a microarchitecture that you have to reverse engineer is somewhat challenging. But even with the Tofino, even though we're compiling our P4 to run down on this chip, like there are phenomena that happen on the Tofino that you're like, what is going on? Like the behavior that I'm seeing does not line up with the code that is running on this chip. And when that type of thing happens, you really need to be able to do things like dynamic tracing. You need to be able to do things like get stack dumps of the architectural state that is running on that chip. And that requires making modifications of the compiler to be able to do those things in the first place. That requires having low-level access to the chip, like over PCI Express, to be able to get the necessary information out of the chip through the registers. It requires all this stuff that we've had for a long time with like x86, but we've never had in the data plane programming space. And so, I did kind of go through maybe we can publish this at some point, but I did do like a good, bad, and the ugly retrospective of Tofino. And I think all the bad things were fixable things, but the ugly things all revolved around a lack of transparency around the chip itself, and were things that were non-technical things that we just couldn't fix. And I was really looking forward to the next revisions of the Tofino and hoping to work with the Intel folks to try to push things in a more transparent direction. Obviously, that didn't happen. I still think the RMT architecture in which Tofino was based was phenomenal. I would love to see it come back again, but that's not the world that we're living in. And unfortunately, the level of complexity and sophistication that ourselves and others needed to operate with the Tofino just wasn't within reach for us because Intel didn't allow that to happen.
They didn't, and I know that folks at Intel, I'm sure, would disagree with us on this. But hand on heart, I believe that the proprietariness of the Tofino stack was an accelerant for their demise. I think I feel that they shackled Tofino by having, because as I mentioned, like the compiler was proprietary. It's now open, which is great, but it's like the docs that you kind of need to write the compiler are still closed. But having just the compiler closed was a real problem, because with P4, I mean, there's a lot of great things about it, but Rai, correct me if I'm wrong, but Rai would tell these stories of like, no, I make a change that should actually result in like less table use, and now this thing doesn't load, and I don't know why. I mean, Rai, am I paraphrasing that correctly?
Yeah, I mean, the architecture is fairly unique. Programming for the Tofino is a lot more like programming for an FPGA than it is for programming for a CPU. And so it's either your program fits and it runs at line rate, meaning it is going to run at the packets per second that the overall hardware is capable of, or it's not going to fit. If you've read about like the RMT architecture in which the Tofino is based, you understand that they're kind of playing this multi-dimensional game of Tetris, where the Tofino is like an explicitly staged hardware device, and you have specific resources and specific stages. And so to get your code to fit on that, it's got to place the code in certain stages. It's got to place the tables in certain stages. It's got to place, other types of resources, like what we call header vector memory in certain stages. And once you make a set of decisions, you might go down a path where it makes it impossible to place tables. So sometimes compiler runs on the Tofino can take an hour to try to get this high dimensional game of Tetris sorted out. And at the end of the day, it can't figure it out. So yes, you can go from code that actually fit on the chip, do nothing but delete P4 code, and then the code doesn't fit on the chip anymore because it's gone down like a different path than the optimizer to try to fit this thing on. So very challenging for the programming's perspective.
And especially challenging when that layer is opaque.
Yeah.
When it's like,
yes.
Okay, so like, fine. Like this is like not the most, like I'm not having a great time over here, but if I've got an open source compiler, I can at least go in there and start to understand why it made the decisions it made, where, and get some idea of what's going on. But that wasn't, I mean, again, they've opened it now, but it's really too little too late because we don't have the documentation necessary. And when Rai was asking the Tofino folks for, and I think this is the other thing, Rai, that I found very frustrating with the whole Tofino adventure, and this has been true at just about every partner and vendor we've spoken with. When we are asking for transparency, what you get a lot of is individual technologists saying like, no, I agree with you. I agree with you, and I see why you're asking for it. And if I were you, I'd be asking for it too, but we're never going to do it. And
yeah, that's definitely a recurring theme with almost all the interactions that I've had.
And that again, that is like, that's not unique to Intel Tofino. That was just like, that's been everybody. And really, and the thing that this is where, as low-level software engineers, we do go a little bit over our mind. It's like, that we're trying to like bind more tightly onto your thing.
That's right. You think after I build my own compiler, I'm going to like, what, switch? Exactly.
I'm trying to, and do you know why I'm trying to bind more tightly on anything? So I can buy more of your parts. Like, you make money on the silicon, right? You know that, right? You don't make money on the compiler.
Yeah.
You don't make, like, why are you should be, I mean, anything that enables software ecosystem is something that you should be giving away as much as possible. But again, this is why I want to avoid that kind of language in the RFD.
No, I know we're kind of in an ISA, maybe not monoculture, but like duo culture. But like there was a time we talk about the 2000s.
Yeah, are we in an ISA duo culture? I don't think we are.
Kinda, right?
No, I don't.
You don't think so?
No. So what's the duo culture? It's just ARM and x86.
Yeah,
we've got RISC-V. We've got the actual ISA that the Tofino runs on is Z80.
Okay.
We've got we've got other ISAs that are we've got some 8051s kicking around.
Okay.
We've got Cortex M, obviously.
Yeah. Okay. No, I take it back.
No, but like, look at the stamp collection over here. This is you're not.
Okay, I take your point, but look at like the mid '90s or whatever, when you've got all the different vendors with all of their different ISAs, and all of their proprietary compilers.
Yes.
Like I just mean that this era, this kind of proprietary kind of hoarding of information. Like there was a analog in the past where for different vendors competing, at least ostensibly, on trying to capture developers, and all of that did go open source. And I think the open source compilers were an accelerant.
Absolutely. And I think that and Rye, this is a point that you've made to anyone who's selling network silicon who will listen, is like, look at what happened with x86 and open source system software with respect to Linux.
Yeah.
And it's like, how did Intel do with the rise of x86? Like, pretty well. I mean, okay, fine. Up until there are no possible routes forward. But they had a good run. They had a good run. And that really needed open source system software.
Yeah.
Right. You weren't going to do that with any proprietary operating system, I don't think.
Yeah.
Oh, and absolutely. I mean, there's absolutely no way, right? Like when you look at like when we have like these big like debugging sessions at Oxide, where and Oxide is a good microcosm of like the systems programming of the world at large, because we build an entire like cloud scale or rack scale computer. And when you look at these debugging sessions where we see some weird behavior at something very high level, and then the networking team gets pulled in because it's always the network at the beginning. So then we start debugging something, and then we start to get to a point where we pull in part of the operating systems team, and then we if something weird is going on with storage systems, we start to bring in the storage team and people that know about the firmware and the FPGAs on the platform that are driving a lot of the hardware. And so we're talking about like tens of millions of lines of code between all of these things, right? All the operating systems code, all the firmware, all the drivers in the operating system, all the infrastructure software. Maybe it's a big complex database that's driving some network traffic in a weird way. And we just need to understand all of this at the same time. And anything that's proprietary in there just creates a barrier where you can't understand what's going on. And I think you can make this, you can build the same scene of actors and characters in other places, of other cloud providers that are building on Linux with open source compilers. And for Rust, we have the open source Rust compiler ecosystem. So if we need to go down to the instruction set architecture level, we can do that. And I think that's necessary for building robust systems, and it's necessary for an ecosystem to take hold, because you have a large group of people that are collectively trying to build robust systems and solve problems that are useful for other people. But you need that diverse community to be able to collaborate over code, something that is very tangible and arms into the problem type of thing.
Yeah, you're right. The power of an ecosystem cannot be overstated.
That's right. So you need an ecosystem. And the question is, what do we need out of hardware to create an ecosystem?
Yeah.
And I feel that I feel it's one of these things that's obvious to anyone doing the software and seemingly not obvious to folks doing the hardware. It's what we're actually asking for. And that's what I tried to do, is these various tiers of what we're actually asking for is for this to be publicly documented. That's it. That is actually what we're asking for. We're asking for the hardware software interface to be, doesn't it sound reasonable when I say it that way?
Very reasonable. So I love though that one of the most successful examples in this document, in the RFD that you wrote, is one that was done unwillingly in the ICE 40. I love that.
Oh, yes. Yeah.
What is the most successful ecosystem of this kind? Arguably the ICE 40 ecosystem.
For FPGAs. Yeah.
But done through reverse engineering.
Yeah.
but it has spawned this thriving ecosystem.
Yeah, exactly. You actually get a true open source ecosystem. We actually tried to explain that to Lattice. Lattice one at some point is like, hey, we should have a call. And we tried to explain to Lattice why we're using their parts. And they're like, we have never heard anyone say this before. Like, we don't know any of this stuff. Like, what are you talking about? And we're like, no, this is like, there's an entire ecosystem out there that's buying your parts. But you begin to realize like, when your part is publicly documented, you don't know, there's no feedback to you or in their case, reverse engineered. There's no feedback to you that like, this is why I bought your part.
Yeah.
I mean, it's like, honestly, we don't know anyone at ST. I mean, I feel that and this is where Robert would be like, Robert is already DMing me, I'm sure, being like, no, actually, like we've had like, okay, we do know some people at ST, but we basically have not, our relationship with ST, we don't need to be tight with ST Microelectronics, which makes our service processor. We don't need to have like sitting in one of those lap because they are the Ne Plus Ultra of public documentation. Their documentation is really, really good. And I remember when we were first setting out, Keith was looking at the STM docs. It's like, these docs are amazing. I'm like, these docs are like, fine. Okay. Yeah. I mean, it's like,
says what it does.
That's what it does. And then I spent some time in some other documentation. I'm like, those docs are amazing.
Wow. They do say what
they do. They do say what they do. Yeah. It's, and their docs are really good. And they're like really complete. I think I found one error in all of their docs, like an address that was like obviously wrong that we had them fix. But I mean, they make really sophisticated parts because they have these SoCs that have all of these blocks on them. So these are documents. These are like 3,000 page documents, and these are all publicly available. Anyone can get them, and you don't need their proprietary layer. And we don't use that, right? We're not using their like PALs and all their stuff. We are actually, we're on the actual hardware.
But it's interesting though, your point about like the feedback goes away, right? The signals that a proprietary company are used to using to measure success,
right,
kind of disappear.
They definitely disappear. Yeah.
And it goes somewhere else.
And now in ST's case, like ST clearly has spent a lot of time and energy documenting this part. So like they've got a hunch that this is important. But to go back to your Lattice example, this was reverse engineered, and Lattice just basically like agreed to not litigate. And so if you're a Lattice field engineer, like you may have like missed that day on the internet, and you just may be totally unaware that there are these people that are using Lattice parts that aren't using any Lattice tooling whatsoever. And it was a weird call because they're just like, what? What are you talking about? I'm like, no, what are you talking about? What do you mean? And I tried to get them to like, no, like this has all been done for you. So you could like really tack into this. And they were just like disoriented. Like we just never heard this before. I just don't know what you're talking about. Like, okay, never mind. We'll just keep buying your parts, I guess. And the problem with Lattice is that like Lattice is great, but it's, Lattice is not Xilinx. It's not Altera, which would actually be, so you're not actually getting which is part of the challenge there. And we love the same thing out of Xilinx and Altera, but we can't. It's like, oh yeah, just go ask Lattice what a big success has been for them. They're like, what are you even talking about? I don't even know this.
We called Lattice. They didn't know.
They didn't know what you're saying. We called Lattice. Exactly. And so but the tier one is this like public documentation. That's all we're asking for. Do what ST is doing, please. Well, we can't do that. It's like, oh my God, no. And again, it's like the things that they can't do, and it will depend because like in Rise world of switching silicon, it's just a darker world, right? And right, I don't mean that. I don't mean that pejoratively. I just mean that like it is just historically much more proprietary.
Yeah, absolutely. Yeah, you don't need to tell me. I'm aware of the darkness in which I live.
And so it's like, okay, no, like public documentation, definitely not. Like, okay, so how about like documenting the stuff privately and just give us some docs that aren't public and just allow us to build software on top of them. And there are a couple examples of that. That's kind of like, okay, that's a little less desirable. Then the kind that now we're getting less desirable is like, no, we don't have any of that stuff. We're not going to give you the documentation. I think there's like, Robert had a comment for me that I need to integrate in here. Often like you've got your documentation is kind of auto-generated from the RTL. Yeah. And it's like, that's rough. When you're looking at documentation that's been auto-generated, because it's like you'll be not surprised to learn there's not a whole lot of narrative about like, what is this register for? It's just kind of like that you kind of register name and address and offset. So, but like even that stuff is valuable, right? So we part of what we need to do is get people to comfortable with giving us the documentation that has been auto-generated. Then the next tier is like, and this is what AMD has done with OpenSil. Like, okay, so AMD has got documentation, which they've got NDA, they've got the public documentation, they've got NDA documentation, then they've got what they call customer internal documentation. They're not making that available. Fine. What they have done though is they've made available their OpenSil project, which uses all that stuff. So great. So you can,
and this is open source, which is effectively encoding.
Yes, that's right. That's right. Yeah. That's right. So you like, okay, you're not going to give me the documentation, but you're going to give me some source code that actually uses the system, and I can use that. Yeah. And not great. It can be, although it's actually sometimes it can be more useful to have like
sometimes more useful. Now you're looking at something that works rather than trying to assemble
easy. Now you put words in my mouth.
Something that they claim works.
Even that backing back off just a little bit. You should like just take one more half step back.
Less shame.
There you go. Exactly. But that's, and then you get to like the lattice tier, the reverse engineered tier, where it's like, okay, this is just like, and you could also have something where, and this does exist, by the way, where you have NDA'd docs that have gotten out into the internet. And generally, like if someone leaves a trade secret that's kind of like lying around, like their litigation is not with you who found it in a dumpster, it's with whomever violated the covenant with the company, right? So, and this is how famously like ASPEED makes these BMCs, and the ASPEED docs are only available under NDA, but widely available on the internet. They've been leaked on the internet. And those docs include, this is what it includes the root password that is in that all ASPEED parts have the same root password.
Right. Which was our Wi-Fi password.
Password.
We leaked it in a photo.
So we leaked it in a photo, which I thought, it was like BMC humor. It was very fun. It was for the right kind of audience. It was very funny. Yeah, it was very meta. Another example that I point out is like Laura's work on the reverse engineering the OPC55. We talk about that. And, obviously now the information that Laura learned about the LPC55 S69 ROM, like anyone could go use that. Like we've documented that for them.
Okay. Question for your editors.
Yes.
Do they see reverse engineer and suggest any softer phrases? Because I feel like in a document like that,
yes.
Like if you think open is hostile, reverse engineer.
Okay. This is a great point. And are you ChatGPT? That's a really insightful point. And boy, if I had to find any criticism with your point, I mean, if you really gave me no alternative, no, this is a great point. The bots did not say anything, but I actually wondered about that. So I actually did, because you're right that open is too scary. So let's just throw out reverse engineer. Like, why don't you? Do you want to put? Is there a section here on IP theft? Like, why don't you put that out there? The thing about reverse engineering is, I feel this is where my legal advisor, Adam Leventhal Esquire, may pull the plug on this. I feel that we software engineering need to stand on our own 2 feet with respect to reverse engineering.
Say more.
It's a natural right, and which is to say, you've given me a blob. We don't have, there's not a EULA that we have with NXP that prevents us from reverse engineering that blob.
I think if you're saying like toughen up, I agree. Like,
yeah, I think we need to be willing to say like, yeah, reverse engineering.
You gave me the blob. Like, I'm going to do what I do. Yeah. If you didn't want to give me the blob, don't give me the blob. Like, encrypt the blob if you want to be a jerk.
But I get to learn how the machine works.
Yeah.
And and I think that that's a natural right. Again, this is where it's like, the phrase natural right seems a little bellicose. Yeah. But no, I think it. So no, I damn it, I left it in there.
I mean, at some point, it's like, what else are you going to do, right? It's like I've been freezing my ass off in the data center, staying at the DC in the morning till like 3 a.m. every single night because some switch is doing some weird thing that is destroying my business and destroying my health. So what am I supposed to do? Because your support engineers are like effectively telling me to turn it off and turn it on again. So
that's right. Hypothetically, exactly. Well, no, and I think, but I do think so. Part of the reason I actually wanted also to leave the term in there is to remind folks, silicon vendors, that like, hey, there are some, and I added a section on this after you and I talked earlier today, Rye, on Joy's Law. It's like there are more smart people outside of your company than there are inside of your company, and always, doesn't matter who you are. And like it is something that people can go do. People can go reverse engineer your interface. That can happen. That can definitely happen. And it's not a threat, although maybe why would I be volunteering that? It's like, I didn't say it was a threat. You were the one who's telling me it's not. You're the one that's telling me menacingly that it's not a threat.
Well, I think it'd be a shame.
Right. I'm just saying it'd be a shame. It'd be a shame. So no, great question. One that ChatGPT was too scared. I should have looked inside of, I'm sure I could get Gemini to be like, God, I really need him to tone down this term, but he's not going to take it well. I better just,
earn some trust first.
I earn some trust first. Exactly. And then you get to like this, this kind of fifth tier, which is like the last usable tier. If you get beyond this, it's like the part's not usable, right? Because it's like, I'm not even going to tell you what it is. Like you got no way of using this. This is like, I'm going to tell you how to use it, but I'm not going to allow you, like, I'm going to, like, the interface is a trade secret. I'm going to whisper to the interface in your ear. You can build some software around it, but you then can't open that software. Right. Or you're limited about what you can do with that software. And in our case, what we want to go do is we want to open it. We want to make sure our entire stack is open source.
Right.
And that's definitely the least desirable. And it's basically like not acceptable, really. Actually, this is where both bots gave me some advice. They wanted me to really sharpen this paragraph. They basically want to be like, hey, no, like you should be really clear. Like, it is unacceptable. Like, we will kick you to the curb. I'm like, yeah, we won't quite kick you to the curb. We'll still use the part.
And so like, this is better than just complete opacity. And we're going to give you some blob, and we're going to give you a different abstraction on top of it. But I would say in some ways, it actually feels worse. It feels worse because like it enables you to do cool stuff, but not like tell anyone. Like it limits the scope of the innovation that you can then do, as opposed to being completely shut out from innovation.
So you're saying that this is allowing you to eat the fruit of a tree of knowledge of good and evil, and you recognize that you are nude.
Kind of, right?
Yeah, right, exactly.
I mean, like I get that, like in many ways, it is technically superior to just a complete opacity,
right?
But it may be worse for your psyche.
Yes, I think that there's a valid point there.
Yeah, and I mean, it's potentially really damaging to your customers, right? So like at Oxide, we're a platform developer, right? We build a platform that has a bunch of different hardware components inside of it. I've spent most of my career in like developing and operating networks. And like at my last job, we were a big customer of Cumulus Linux. So we bought a lot of Cumulus gear, and they had a pretty good disposition toward open source, but they also had these bilateral relationships with the ASIC vendors where they had access to the secret sauce, or let's not even call it the secret sauce, the hardware software interface. But we as the customer, as the end operator of the system, depending on these for our organization, didn't have access to that. And so it's extremely it doesn't do anybody any good to have the platform vendor be able to look at this, but leave the operators and the ultimate end users of this technology in the dark. And that's one of the big reasons why I came to Oxide, because I wanted to change that for networking, and hope to be able to change that while I'm here at Oxide.
It even seems to create an obstacle, right? Then becomes, what can I share with the customer?
Right.
Because like, I know secret knowledge that I have.
I know the secret knowledge of how to use this thing. It's like,
yeah, exactly.
I know the top secret knowledge of like where the gas pedal is. Definitely can't tell them that. Don't tell them that. Yeah, and Rye, you're exactly right. And this is, you had the point that transparency is transitive, and that you can only, and we need to be transparent all the way up to the stack to that end operator sitting in the data center should be able to have the support of an entire stack that can help them understand what's actually failing here. So that's kind of like
that's the world we're trying to build, and it's not a question of if, it's a question of when. But
it's the question of when.
We'll see of when the when will be.
That's right. So okay, so then we get to like the arguments. I'm trying to collect like what are the stated arguments against transparency, and you'll do notice that I did differentiate between stated arguments and the unstated arguments.
I like that you put them all in quotes too. Just
But did you like that? Yeah. The and how did I do on that? Did I make them?
I know this is not the first time on the podcast we've mentioned the 4 questions from the Passover.
Oh yeah, that's right. Yeah. I love the 4 questions.
It felt very like wicked child, simple child
right,
stuff.
Right. Okay, that's good. So, where are we? So, transparency will allow someone to copy me.
Yeah, felt very simple child.
Yes. Yeah. No, I think you're right, and I think, what I have found when these stated arguments, so transparency. So, if I open my interface, someone else is going to copy it. It's like, are you kidding me? What? Like, no one cares. No. Do you know what's much more likely? You're going to die. That's much more likely. You're going to be lucky if the entire universe cares so much about your interface that they're scrambling to copy it. Man, you'd be so lucky.
It's like, let's walk this forward. You open the thing, you build such a thriving ecosystem.
Yes,
that it becomes that the hardware software interface that you have defined because such a standard that the only way to operate is by mimicking your hardware software interface, and then a competitor comes along who can do it better than you, then like why do you
exist?
Why do you deserve to exist?
You deserve to exist.
Like you fumbled everything.
Yes. And actually this reminds me when in the first time I can remember open source coming up at Sun with respect to Solaris was, I think, 1997. I could be off by like a year. It could be as late as 1998. But I remember thinking, and this obviously my thinking on this changed pretty quickly, and in part because of this conversation, I remember thinking like having this same thought. Like I had this thought of like, because this is very much the era of proprietary operating systems. And Linux basically doesn't exist. I mean, it exists, but it exists, but it's not being used. BSDs exist, but they're fighting with themselves. And this is the era of the proprietary RISC Unisys. And I remember telling the VP, like, I'm just worried that a competitor would steal our kernel memory allocator, right? Slav allocator, right? Written by our colleague, Jeff Bonwick. And he just looked me dead in the eyes like, Brian, if someone steals our memory allocator and we can't outcompete that company, if their strategy is to follow whatever we're doing with the memory allocator and we can't outcompete them, we don't deserve it.
Yeah.
And I'm like, yeah, damn, that's really right.
Yeah. Whatever. I think that's the only attitude that's not a kind of cowardly attitude.
Yeah.
I mean, I think the alternative is, I think, along the lines of what you've observed about inherited wealth.
Yes.
Like preserving wealth.
Yes. 100%. Yes. Yeah.
Continuing to innovate.
Continue to innovate. No, absolutely. Absolutely. So that argument is simple child. I'm with you on simple child. Then you get to the transparency will be a support burden. We get this one a lot. That like I can't support you if you do this. And we're like, we don't want you to support us. I mean, we don't, you know what I mean? It's like hard to, and right, you walked this a bunch of times. You're just like, we are going to like, if you give us the interface, we won't need your support. And
they can't support us if they give us the interface, which is exactly what they want, right? We don't need their support. And
then they're like, kind of like, we don't believe you. Basically, it's like, no, we're just not going to be able to support you. It's like, we don't want your support. And that one, I feel we've just had to earn. And I think that we have earned it with a couple of companies. And I don't think I'm speaking out of turn to say we've really earned it with AMD. I think AMD had this exact objection to what we wanted to go do with respect to holistic boot.
Yeah.
And they're like, it's going to be a huge support burden. And we really made the case that like, no, we are going to be self-supporting. And when we, to their credit, people inside of AMD were really trying to make that case for us, and like they could see that too. But it really took just time and us really earning it. And our fortunately, the folks we work closely with at AMD now are terrific advocates for us. Shout out to Will inside of AMD, who are terrific advocates for us. And I'll be like, when the questions that when you guys do have a question, it's because like, by the way, like the part is broken. When you come to us, because we are able to be sure that we are not misunderstanding something because you give us the interface. I mean, it's so important. And so, right, I don't know. I feel like we've not really found a way to, that one is just like one we have to, it's very hard to talk people out of this argument because they're like, you're going to be a support burden. It's like, no, we're not. And, again, I think we've earned it at a couple of companies, but it's hard to make that argument in advance.
Yeah, we definitely have to re-earn it every single time. Every single hardware vendor that we talk to, it's a new conversation. We go through this, and ultimately it winds up working.
Yeah. This RFD is an attempt to not have to re-earn it from zero every time. So I'm hoping we can get there. But so this is one that can get people. The one is that the wise child, wicked child? It's simple, wicked, wise.
They're a bunch of children.
They're a bunch of children. It's like, I don't even keep them straight anymore. I don't even know. Is that one the wicked one? Wicked one is, I don't know. Then you get to transparency is a security risk. And that can be frustrating. Because that's bullshit.
Yes.
That's just absolute bullshit.
And that's the argument against any kind of open, I think.
Yeah, yes. Any kind of transparency.
Any kind of transparency.
Yes. And this is the Kirchhoff's principle. It's kind of this interesting. Yeah. So this is an interesting a principle from August Kirchhoff's, who is a 19th century Dutchman who had the observation that in a cryptographic system, you should be able to make public everything except for the key, and that should not represent a vulnerability.
Right.
And right on, like Kirchhoff's, just August. You're killing it over there. I don't know how you're doing this in the 19th century. It's kind of I kind of want to read about this guy. I don't know.
Yeah.
Maybe he doesn't exist. Maybe this is is that possible? Someone like just created a Wikipedia. And you know what I'm going to do?
The ChatGPT.
The ChatGPT. I'm going to create like some 19th century, but people won't actually. I can create something that's plausible, and then I can just win this argument. I'm sure this person actually exists. But I think so this is bullshit. Rye, have you heard this more than? I mean, I've heard this at least once. It gets chased out of the room pretty quickly.
I hear this continuously. It's always there, especially in the networking space. It's there a lot.
And you know what's actually also bonkers is when you have someone who is making that argument to someone for whom security is extremely important, like who is much more sophisticated about security than you are. When I'm, it's like you chip vendor are making that argument to a federal government or to someone who does security for a living. It's like, yeah, no, they,
I don't claim to be particularly sophisticated when it comes to security, but I do imagine
Adam Levital, security researcher.
I do imagine that like part of the upshot of this is that a lack of transparency here means that, like, let's say there is a vulnerability.
Right.
Then it will be
only the bad guys know.
Only the worst guys.
Only the bad guys know. Exactly.
Well-funded business who would know.
Yeah, only the state actors.
Only the state actors who would then be able to exploit it in the worst ways possible.
Yes.
As opposed to
this is about in the conversation where this argument turns into something else. This is where they're like, okay, I don't want to have this. Like, okay, yeah, I'd like this. This one is kind of falling apart in front of me. Actually, I want to go back to something else. I want to go back to let me go back to someone stealing my IP. Now that,
but this is a lazy argument fundamentally.
Lazy argument.
Right? This is not this is something that feels right on its face and doesn't bear scrutiny. Certainly not in 2025.
That's right. Does not bear scrutiny is an absolute redux of the arguments against open source that I feel have all been debunked.
Yes.
And being transparent makes something more secure. I mean, that's what makes the XZ vulnerability so extraordinary, is that they did pull it off in the open, and it was really, really hard. Much harder to pull that thing off in the open.
Yes.
Than it would have been in a proprietary toolchain. So, I mean, yeah, just that one is just bonkers. Another one you'll get is like, no, listen, I want to make it transparent, but I can't do that because of another agreement that I have with an IP provider. So with someone who's providing a component of my chip, that's what's preventing me from my hands are tied. My hands are tied.
This is also another, like, I mean, we've seen this, like the lawyers in control.
Yes.
Like a Department of No.
A Department of No. And then you'll be like, okay, like what? Okay. So let's get that agreement in front of us. Like, well, I'm not a lawyer. Like, I'm not going to have to no, I actually don't know anything about it. Like, well, okay.
Does anyone there?
Why? How do you know that would violate that agreement? Because it's like it's a very strange. I mean, it's a very stringent agreement to say that like I'm using your IP, and this is going to constitute an interface to my part, and now I'm very encumbered about how that. I mean, it's like I have a lot of follow-up questions.
Yeah, especially because we're not saying like open source the RTL.
No, that's it.
The interface, right?
The interface. So you're like that IP. Like, how does that violate your agreement?
Right.
Just seems very strange.
Yeah.
I don't know. Have you heard of this one, Ryan? Have you heard this one in your travels? Is this a common one or is this an uncommon one?
It's extremely common in networking. Network ASICs are built out of a bunch of different IPs from a bunch of different shops, usually, unless you're someone with an enormous amount of resources. Like I think Cisco makes some of their own chips completely without buying IP from others. But I think most of the medium size enterprises and down that are making networking ASICs are buying IP from somebody, particularly from their EDA vendor, probably buying SerDes IP and things like that.
Yeah.
PCI Express core IP. Things like that come with restrictions. So it's.
But I was really surprised that those restrictions include no, you can't make available. So you're going to buy this PCIe block from me, which has a bunch of register space associated with it, and oh my god, no, you can't disclose that register space to anybody.
This is just FUD. This is just word of mouth FUD. That is again doesn't bear scrutiny. And it's look, if we do anything with this thing, we're gonna have to talk to the legal department. And I'm not going to do that. You're not going to do that. So
right. Yes.
Moving forward.
It's moving forward. You're right. Exactly. It's kind of a table veto. Yes. I think so too.
Yep.
Although I like this, you're much more bellicose than I am on this one. I'm going to bring you into the conversation next time. You're extremely unreasonable. I'm actually, no, I've got someone even more unreasonable. Although you thought I was bad cop. You're going to, after
love me
after crazy cop, you'll be begging for bad cop.
Yeah.
I agree with you. But I also think on this one, there is also a counter. And Ryan, I don't know, do you is this one more legit than we're giving it credit for? Do you think?
It's definitely a barrier that I encounter a lot. That doesn't say anything about its legitimacy, but I mean,
my position on this one. So my position on this one is okay, I'm going to accept this, that you've got some agreements with some IP providers that are preventing you from making some of the control interface available. We're going to put rings around those. And we're going to say, because I do think you get into, this is being used as part of an all or nothing argument. I can't make any of my control interface transparent because some of it is encumbered. And I think it's no, we're going to take the sum of it that it's encumbered and let's start, let's get into the interface here. We're going to have to get detail oriented. You don't get to just not give us any control interface to this thing. You're gonna and let's start drawing some lines around some things. Let's get some we can. This is if this is a valid argument, I think that there's lots of room for compromise here.
I think it's a combination of the fact that this is already something that they don't really want to do, and this is just an external force that they can bring into the conversation. And I think a lot of this for networking in particular has to do when things go analog. A lot of the chip vendors don't have the analog circuit expertise in-house.
Right.
So they'll buy the analog parts of the chip from somebody else, and that'll be encumbered. And so it's challenging.
Right, those are kinds of the aspects of the parts that not that we don't care about that, but it's that feels that's the part of the interface that we are least concerned about from the perspective of that transitive transparency. Is that, that's that true?
Yeah, I think so. But I think for it's kind of all tied up in this big nasty pile of spaghetti in terms of the underlying IP mess, which is
right.
Again, I'm not saying this is a legitimate thing, but it happens a lot, and it sucks.
Yeah,
I think it's a scare tactic. I think it's oh, do you want to get the lawyers involved?
Yeah. So my way of saying okay, no, let's wade in and let's start marking each of these interfaces about how they're encumbered. And your answer of well, they're all encumbered. It's no, then you're just that's disingenuous. You know what I mean? It's let's do the hard work here and figure out where because one of the nice things about these things, about these complicated parts, of course, there's a bunch that's programmatic about their creation. So these folks have their registers or their control interfaces are defined in massive XML files.
Right.
So like, great, we're going to have an attribute on one of these things where we can go tag it with it, which we probably should anyway. I mean, if you're so, aren't you like concerned? Like you've got this agreement, this toothy agreement that you just told me about that you're so scared of. Like, don't you want to be very careful about how you mark that interface in your, you're not careful because no such agreement. Anyway, yeah, whatever.
Just do one of good cop or bad cop. Doing both is going to be tricky.
Don't threaten me with a good time. I could definitely do both good cop and bad cop. I've done that plenty. I can do good cop, bad cop, and crazy cop. It really keeps people
one-man show.
It's a one-man show. It keeps people off balance. You kind of like, they really don't know who they're dealing with at any given moment. Okay, so those are the stated arguments. Now we get to the unstated arguments. And because I feel that I think like, and Ryan, it sounds like you are not as willing to go quite as far. Adam and I are both think that like the transparency is violating another agreement. I think it's total bullshit. And you're like, I just can't speculate, but I hear it a lot. But I do think that there are these unstated arguments that actually are the root of a lot of the actual real opposition. Because the thing is, when you're arguing with someone about these things, about why they can't be transparent, and you're chasing them around the room, like they'll make the security argument. Then you knock that one down, and then they kind of show up like, well, now I'm afraid that people are going to steal it. Okay, so you knock that one down. Oh, actually, I've got this other agreement with an IP provider. And then you kind of, it's like, and you knock that one down. It's like, well, it's a security issue. It's like, okay, so it's all of these things. And it's actually none of them, because there's a deeper reason. And this is where you get into the more emotional aspects of engineering that I am convinced is actually the real reasons. Just as like I'm convinced that executive feelings of inadequacy and aging is actually what's behind RTO initiatives. Yeah. I am convinced that these kind of emotions are actually what's behind a lot of this reticence.
Absolutely. Absolutely. And I think the fact that you start each of these with, I'm afraid that, is spot on.
Right?
Because it is fear.
It is fear. It's fear. And because it is fear, it's got like, people don't want to say they're afraid. So they kind of come out with these outgrowths that are
like, if you're never going to be in a vendor meeting where like I'm afraid.
Right. So okay,
these things are going to happen.
So I just want you to point to the section in the RFD. You don't have to tell me what it is. You don't have to tell me, just point to the section in the RFD that captures your fear. Okay. One, I think, and sometimes people are explicit about this, but often you kind of have to dig a bit. I'm afraid that my docs are incomplete. Like that's very common. It's just not ready yet.
Yeah, and I mean, we've all felt that. I think all felt on like anything that we've been transparent about, turned over to the open.
Yes,
like I have not explained this thing well enough.
Yes, and this was the subject of a rather caustic email I may have sent to our colleagues in CFS.
Oh, yeah, I remember that.
Where as far as I'm concerned, like Jeff Bonwick had an enormous influence on us. I was actually joking with Eliza recently. I'm like, you are like a descendant of Jeff, because Jeff influenced me, influenced you. We influenced Robert. Robert never worked directly with Jeff, I don't think, but I definitely got that, like inherited that kind of big theory. And obviously Eliza was doing this before Oxide, but Eliza also writes, I don't know if you've been in Eliza comments, they're just extraordinary, great big theory comments, lots of ASCII art, really good stuff. And we've got a lot of colleagues that do that. And I think like Bonwick to me is at like the kind of the headwaters of that, but ZFS was not well commented.
Yes.
And I feel that ZFS was not well commented because Bonwick felt that ZFS was not done.
Huh.
Because the way that he did, if you look at the way he wrote his big theory statements, he would do it as a final step.
Oh, really? I didn't know that.
Yeah.
That's really interesting.
Yeah, and I do it too. I'm the same way. All of like the dtrace comments, I did as a last thing, not a first thing.
Huh.
And I think it's because like, I now like this is like the last step. I understand this whole thing, and I am convinced that ZFS escaped. ZFS, it's like he came in one morning and the cage bars had been bent and the window had been shattered and there were footprints going into the street.
I think there's an aspect of it. It needed to be done, so it was done.
Yeah, and I think in particular, like ZFS kind of escaped his ability to hold it all on his head.
Yeah.
And like there was no ZIO pipeline block comment.
Yeah.
There was no big theory statement. Like it's like, Jeff, we've got these extraordinary big theory statements for things that are actually like much simpler in comparison. It's like,
I remember one on dividing by a billion or something like that.
yeah. The Spark Station 2 divide by a billion with shifts, divide by a billion and then mod a billion.
It was beautiful.
Beautiful with shifts and adds. And that comment, we got to go find that comment because I think it was open source, but then ripped out when the SS2 support was ripped out.
Right.
It's like, you can't just delete this comment. This comment is so gorgeous. It's amazing. But we didn't see that for ZFS. And I, at a point of frustration, do you remember this when
Yes, I'll be very interested to see if we remember it the same way.
I am certain that we will not remember it the same way. But I got so frustrated with the poor level of commenting in ZFS that I compared it to the rest of the system.
Yeah, you did like a LC basically on like is a comment is a code.
Is a comment is a code, and like what is the fraction, and like where are we in that?
Yes,
and ZFS was bottom decile.
Yes. And I remember you showing me that email before you sent it.
Oh, yeah. And what'd you say?
I said, are you sending this email to feel a different way, or are you sending this way to inspire them to change?
What did I say?
And you said the first one.
Oh, yeah. I was like, I just sent it. You're like, what? I just sent it. Sorry.
Yeah.
This is a classic, well, you're going to do what you're going to do anyway.
Yeah. And
I did.
What happened afterwards? Did they take that to heart and comment things?
Yeah, I definitely did do permanent damage to any relationships with that. No, it was not good. It was not good. Yeah. Well, look, you're right. Is that what you want to hear?
Well,
yeah,
first time I've heard it.
That's right. It's you've been right a lot, but you were definitely okay. Yeah. If you tried to talk me out of that, I don't regret sending it. Someone needed to say it. I think a way of saying I definitely understand where this is coming from.
Yeah. Yes. Like if I can't do a good job of it, I kind of don't want to do it.
I don't want to do it.
Yeah.
Yeah. And like I know it's not done yet, and I'm like, I wish this were in a better state, so I'm not going to make it available. And it's like you got to just get over that.
Yeah.
And you've got to. And this is where I feel like we're kind of like people's doctor. It's like, look, I've seen so many nude bodies. I just don't like. I've seen so much terrible documentation and source code. Like nothing's going to surprise me. Just please take your clothes off and I'll be back in 2 minutes.
The other great benefit of being lazy is that it is a great source of prioritization. Like if the parts that need to be better documented will find you. Like the people will educate you about what actually needs to be documented well.
Maybe in an email with many people on the 2 line.
That's right. Hopefully kindly. But it also will educate you about like, you could easily have spent all your time documenting the stuff that people don't care about.
Right. Yeah.
Anyway, procrastination, just saying.
But I also do think that like, there's some truth to the fact that when the system kind of like, you've kind of barely got it working, you have a hard time documenting. Like the act of documentation will kind of reveal that like, this is really not the right way to do it.
No, I actually, so I went through, I was speaking about ZFS. There was a time when I was at Delphix when I was kind of sitting with Matt Ahrens and getting the oral history of ZFS and then writing it in blog posts and then comments. And part of this, like the old ZFS write throttle, once you started like writing down the principles of it, sounded bananas.
Right.
You're like, wait, why all of a sudden are we like injecting a 10 millisecond delay? Like what, is there a principle behind this, or is this just the thing that is happening?
Yeah.
But you're right. As you start to write it down and put it into a paragraph, you're like, wait a minute.
Well, we can't ship this.
Right.
Don't give them this interface. Yeah, exactly. So I think that I empathize with it, but you got to get over it.
100%.
Like I get it. I get where you're coming from. It's incomplete. It'll never be complete. Give it to me anyway, please.
Yep.
I'm afraid that my source code has got bugs. I get it. Me too.
Spoiler.
Spoiler. Exactly. Well, and it's like maybe your HAL layer is so thin that it doesn't have bugs, in which case just give us the goddamn interface. And if your HAL layer is actually sophisticated, it's going to have bugs.
Yes.
So yeah, spoiler alert, it's got bugs. So same thing. Like get over yourself and I'm afraid that it will reveal mistakes where you are going to see some like design decisions that I've made that I'm really, and it's like, sometimes it's like, I'm willing to give you this documentation, but I don't want to give the world this documentation because I don't want the world to see this thing that I've done that's really not great. But But like, again, get over it.
It's in the same category of bugs, sort of. I guess
Yeah.
they're like bugs that you can't fix. But it's still like, yeah, it is what it is. You'll get it next time.
Right. So, and then
if it is revealing mistakes, like if the act of opening up your interface or your source code is revealing mistakes, then it's going to reveal mistakes at design or engineering time instead of, operation time when it's going to cause your customers an outage.
Or it may be the case that those mistakes are exactly the things that are going to be of most interest as you're like when everything is falling apart. Understanding that, like, yeah, I'm unfortunately at a part where this part is like not doing its best job.
Oh my God, you're reminding me of the Toshiba firmware issue where you're like, you have a 3,000 millisecond sleep somewhere in your firmware. Like, if you can give me the source code, I'm going to be able to find where but exactly, you're just like, I'm sure I'm in some like XXX, I hope we don't get here kind of code, but like, that's the stuff that's going to bite you.
Yeah.
Is the stuff that are like or where you're working around some other issue.
Right. The things that you're itchiest about. Yes. Like that's the thing I care most about.
I care most about that. And it's like, not because, again, it's like, I don't care about like, great. Yeah.
And also I paid for the thing already. Like
I've already bought the damn thing. I'm not returning it. Exactly. So yeah, you got to just get over that one. Unfortunately, I think we are in an era where errata are more publicly available. I do think that like Spectrum Meltdown kind of helped on that, where Intel's first reaction on that was really not great, and they kind of became progressively more public in their disclosure earlier. I mean, still plenty to go. I shouldn't be overly forgiving, but I do think it's like, look, you got to treat this like an errata. This is going to have to be public. So you just get over yourself. And then we get to and Ryan, this is the paragraph that I added after you and I went back and forth today, because I think this is a big reason. And Ryan, this is something that you'd hopefully I'm kind of paraphrasing what your observation correctly, but this is something that we've heard from other folks who are trying to prevail inside of their companies, where like they're up against some other wall, and I think it is literally fear of like, I just don't want someone else to write the software. I just don't think they can do it.
Yeah, I hear this all the time, right? The vendor of whatever chip is worried about getting a bad rap because someone else is going to write software around their chip. It's not going to behave in the way that they wrote the software, and they think that this is going to get out, and people are going to think that the part is shit. And that's as irrational as that may sound to you or me, that is something I hear all the time.
And I think that I agree with you. And I think that is the more charitable spin on it. Like, I'm worried about reputational damage, and like, reputational damage on my software running on your part. I mean, it's like, really kind of stretches credulity there. I actually think that there's kind of a less charitable interpretation, which is like, this chip is being handed to you, down to you mere mortals. And you mere mortals are not able, like, in fact, if you were able to write better software than the software that I'm writing for my own part, what would that say about my engineering? Like, they kind of put themselves in this kind of competition with their own customers emotionally, I think. And obviously it pains me greatly to give Bill Joy any credit that he's not already due. I mean, this must have stood out to you, Adam, as
I think I saw a draft before that line was
before Joy's Law. Yeah.
But I saw someone some comment on it. I thought that was great.
But like, I do like the end, because this is in reaction to Microsoft, who Bill Joy, I think rightfully accused of being IQ monopolists, of like, I mean, it's kind of amazing to me that Microsoft could think that they are like the smartest people on the planet. It just shows how like ignorant of this other world of computing they were, that they were only looking like, yes, like, congratulations, you are the biggest fish in the personal computing pond. Like, there's this whole other vista of computing in terms of minis and workstations and mainframes. And it's like, sorry, you're actually, there are smart people everywhere. And I do love this kind of distillation of it. Like, no matter who you are, most of the smartest people in the world work for someone else. And I really think that you've got to, building a software ecosystem means internalizing that, really internalizing that. And I think because you think about this is honestly where just from the at the top, we're talking about Intel's Foundry issue. Intel has not internalized this on the Foundry side, right? And I think a lot of where folks they want a software ecosystem to exist, but I think they're unwilling to internalize that. Okay, if you want a software ecosystem to exist, you need to acknowledge that there are more smart people outside your company than in it. And
I think that taps into another source of fear, which is, will I still have my job?
Yeah, for sure.
Which is real, but embracing the community, right?
Right.
Be a leader of that ecosystem rather than an opponent of it.
And I just feel we would talk about how making the case for dtrace for people, and until they had used it to actually solve a problem, there was kind of a bit that they couldn't get over the hump of.
Yeah.
I kind of feel until you have had someone that you've never met before kind of swoop down with something extraordinary, an observation, a piece of software they built on your thing, an application of your thing, something you just did not anticipate. You know what I mean?
Yeah.
Where you just don't appreciate this.
There is something magical about it. Just a person you never met, never spoken with.
Yes.
Appearing out of the ether and doing something amazing, or just contributing, making the thing better,
finding a bug, using it there. I kind of feel that has to happen to you before you really appreciate it.
Yeah.
I don't know, Ryan. What do you make of all this?
Yeah, I mean, an observation about all four of these points is that they're all going to be true no matter what, transparent or not, right? So I'm afraid my documentation is incomplete. Well, congratulations. Documentation is always going to be incomplete. Going back to being a large Cumulus customer in my last life, they put their documents on GitHub and we could submit pull requests. And their documents were much better because of that, because me and a whole bunch of their other users provided them with not just feedback, but hey, this is how I would change this documentation to make life better for operators. And so I'm afraid my documentation is complete. Well, it's always going to be incomplete, but it's going to be way more incomplete if you're not transparent about it. Afraid my source code has bugs. It's always going to have bugs, right? Why did I write my own data plane code? Not because I thought my code was going to be better than the Cisco vector processor that was, in its heyday in 2016. But, because I could understand the bugs. And there's always going to be bugs. That's just how software works. Afraid of revealing mistakes. It's much better to reveal mistakes in code than it is at operations time. And I'm afraid of someone else writing the software. I think that's the hallmark of success, right? If your software outlives you, then you've been successful. When I came to Oxide, that was kind of the first time in my career I was stepping away from a large scale software project that I had built. And one of the most gratifying things for me is that software project is still surviving and thriving in the community that exists in without me. And that's what you want.
Yeah. Yeah, that's exactly it. And so then you get and right, I think you got a good point. These are true no matter what, whether you're transparent or not. So you might as well be transparent. And again, you need this to be able to actually build that software ecosystem. And by the way, look at Linux and x86, Intel in particular. Intel was successful in the server space because they had an ecosystem. And, Ryan, I know you kind of make this point until you're hoarse about other domains should look to that as that's a path to follow. I think also be interested to know what your take is on this, or what folks in the chat think. I think this is a big part of NVIDIA's success. So, because NVIDIA is very proprietary on the control interfaces, but has actually been very transparent on PTX and on CUDA. Have been very thoroughly documented, just like what the DeepSeek folks are able to do. They were able to code directly onto PTX. And it's yes, that's being translated into something else on the part, but they were able to deliver magical results for themselves by coding straight to PTX. You don't actually need to code to CUDA.
Yeah, and I'm definitely not a GPU expert, but I definitely have looked at the NVIDIA space just to see what they're doing there. And they have PTX, which hooks into LLVM, which is has a very well understood SSA compiler model. So you can, while you don't necessarily have what their assembler is compiling down to in the true instruction set architecture, I don't believe for the NVIDIA chips, you do have a very well understood low level single static assignment compiler model that you can reason about, which is saying a lot.
Yeah, and how's that working out for NVIDIA? I feel my understanding is thanks to Pat Gelsinger's departure of Intel and the abandonment of Larrabee, NVIDIA is doing very well.
That's right.
So I think that there are another one of these cases for transparency, kind of paradoxically, because you don't think of NVIDIA as being a transparent company necessarily, because the control interfaces are still proprietary.
Yeah.
But I also think that NVIDIA would be even more successful if the control interfaces were, although
That's bonkers.
What
does that even mean?
Am I hallucinating that earlier this year, NVIDIA said that they were going to provide an actual open source Linux driver for some segment of their GPUs? Is that true?
I mean, they certainly should. It's certainly, if not true, it certainly should be true. Because I think NVIDIA's got more to gain. I think they got more to gain by doing it. I think they would actually be, they would allow their chips to be used in more systems in ways that and again, I mean, I think they're doing fine without my.
Maybe they're listening though.
Maybe they're listening. Jensen's like, I'll take a note. I could be even okay. Thanks. So we think that all of this obviously should be obvious to a vendor of silicon, because like you're helping yourself sell more parts. Like do you know how many open source companies would kill for this kind of revenue model? Where it's like, in order to use my open source software, you got to buy a license key that's like a $3,000 license key at 300 watt TDP or whatever it is. It's like the fact that like the software only runs on your part. You make money by selling the part. Why are you not? How is this not obvious? This is usually in the part of the conversation where I'm like begging. This is like you get to like, now I've oscillated from psycho cop and now I'm like back in the good cop, where I'm just like, come on, just
anger into bargaining.
Just help me reason with that guy. I know that guy really loses the temper. You're that guy though. And I do think it's worth, like, if you insist on being opaque, you are forcing people to keep their bag packed. Because you're saying like, no, like, I'm sorry, we're going to be opaque. There's going to be a hard interface here. Like, all right, well, there's a hard interface there. Then like, you're actually forcing me to be insulated from you in a way that kind of preserves my future optionality. Like, you shouldn't want to do that.
That's right. I'm saying I want to invest. I'm saying I want to build a bunch of software that makes me even more tightly coupled.
I want us to like have a bunch of babies together. I want us to like, I want to move in.
And you're saying I get to leave a toothbrush and that's it.
That's it. And it's like, okay, well, I'm just saying, like, I'm kind of a catch over here. So I don't know. This is where it breaks down. But I think that like that there's a real peril that like and by the way, if the thing that comes along that you kind of preserve my optionality, if the thing that comes along, by the way, is transparent, like you're never going to get back in.
Right.
And this is kind of this is what has arguably, not that TSMC is necessarily transparent, but this is the problem that Intel has with that TSMC mode. It's like, I don't know how you're getting back in. You now have to do something crazy to get back in. And it's going to be really, really hard to get back in once you lose a test. It's like, so just don't do that.
Right. If you want to get crazy, you know who to call.
You know who to call. Exactly. I'm your man. I'm telling you, CEO just for like a month, 90 days.
It's like some Elon stuff right now.
I know. I know. It's like Bruce Millions for Intel CEO. This is a very weird kind of. All right. I need to stop. I actually don't want that. So I need to stop kind of obviously fantasize about it. But hopefully this is like, spells it out. Yeah. Adam, are you sold? Will you make your hardware software interface transparent?
Grudgingly, but yes, I'll overcome my fears and go for it.
Are you going to stop making this bullshit argument about these legal agreements that we both know don't exist?
No, let's get the lawyers in. They're nice. They're fun.
They're fun. Exactly. So there we go. That's how we got here.
I think it's great. And I don't know that I think like your email to the ZFS folks.
Yeah. Yeah. How does it rank in terms of like level of,
first of all, I
as caustic?
Much less caustic, but I just don't know what's going to change this industry. Like, I don't know what.
No, we're going to change it. We are going to change it.
Sweet. Okay.
Yes.
Good.
This is what's going to change. We're going to change it.
Okay.
We, the people, we're going to change it. I really do think that we are, I think because, so here's the reason for optimism. The reason for optimism is this is such a win that when it happens, a la x86, it just goes supernova.
I'm with you. We need that kind of patient zero of this. Like,
yes.
You need to see for folks to be able to see what they could be, what could happen, and then be able to imagine themselves doing it, because it will take courage. Right?
Yes,
it will take courage from engineers and courage from leadership.
That's right,
and even courage from lawyers. That's right.
Some lawyerly courage. Lawyers are going to do what they're. And the lawyers, I think people blame the lawyers unfairly. The lawyers are kind of like, leave me out of this. Like you signed the agreement. I told you what you're agreeing to and not agreeing to. Like that
was your decision.
That was your decision. Exactly. But yeah, I mean, it would be great for like an FPGA. I think that, I think an FPGA could do something extraordinary by really I mean, I don't know that that's going to, I mean, we've got Lattice, but we're not seeing it. And I think, I feel I had a 3-year per day. I had a heady year for open EDA predictions that have all fallen flat. I feel like one of those years in there, I don't know. Yeah. 2022, 2023, one of the years I was on an open EDA bender.
And I think in the networking space, we can definitely point to what hasn't worked. I don't think we have to make an argument that programmability is valuable, but if you look at programmable data plane networking technologies, none of them have survived, right? They're all in the dumpster of time. And so clearly, something isn't going right. We think we have a beat on the things that aren't going right. So hopefully we can convince some people of that. In my computer closet at home, I have a reminder hanging up of a Netronome card, just sitting on my top shelf, reminding me of the perils of opacity. The Netronome was an amazing piece of hardware, and it absolutely flopped in the market. So I just keep that as a little reminder.
Absolutely. I mean, that's it. Like go in, like walk through the cemetery. And I mean, I did have a line in there that I did delete, encouraging people to take a stroll, like any stroll through the cemetery, go read the tombstones in the cemetery. And these are not transparent parts. They're opaque parts. And honestly, it's like, it is part of Tofino's epitaph, is like it opened on its deathbed too late. And he didn't even open all of it. Like we can't even get the microarchitecture document for like a dead part. It's like, it's too late. So I think that we can prevail here. Okay, here's the other reason I think we can prevail. Because it's so many. Part of the reason I wrote the RFD is because of the number of times we get people inside of these companies that absolutely agree with us, and they are trying to win arguments internally. So just like open source, it's like when the world was very reluctant to go open, but once the dam broke, and and then the dam like got weird, and things relicensed themselves, and it's like that a bunch of weird stuff happened. But we're not asking people to open source anything. We're asking for true open systems. So I'm optimistic.
Good.
Rye, you optimistic? We're going to do this thing.
I'm optimistic about us achieving our goals. Optimistic about when, we'll see.
I think I heard Rye at some point say that we're going to have these open, these transparent hardware software interfaces because we're going to be building the ASIC.
I think that we look at some point. That's what it takes. That's
what it's going to take. I mean, I build my own little ASICs in my spare time because I don't know. That's just how I'm wired.
Same.
But yeah. We'll be doing that eventually.
Yeah, I think, and where we talk about it most frequently is the silicon that we've been kind of frustrated with, and whether it's and we know it's obviously really hard. It's not something we would do casually, but it does feel like if we have to, that's what we'll do. We don't want to necessarily do that. We would love to be able to partner with folks. So help us out, partners, and let us know if you've encountered arguments that we missed. Let us know, but. Rye, thank you again for inspiring this to be written. And again, I spent a lot of time talking with Robert about this as well. So this is definitely representing a lot of us, and the discussions and arguments we have had. Arguments, wrong word, but the kind of how we persuade companies. And thank you all. Like there are a bunch of folks inside of our partners that have really been trying to make these arguments internally. And we're really trying to put arrows in their quiver because they've been huge advocates for Oxide and for our approach because they see that it's really important.
Yeah, thank you very much for having me tonight. And this, like I told you earlier, this gets at the core of why I came to Oxide. So really excited to make a difference here, and looking forward to living in that future world where operators can actually understand the metal beneath them.
Amen. Here's to understanding the metal, and here's to transparent hardware software interfaces. All right. Thanks, everyone.